Hello students, in the previous video I discussed with you about the properties of ammonia. In this video we are going to discuss about the properties of ammonium hydroxide, how you get ammonium hydroxide and what are the properties. So keep watching. Properties of ammonium hydroxide. An aqueous solution of ammonia is called alkaline in nature and it is called ammonium hydroxide. NH3 plus H2O will give NH4OH, ammonium hydroxide is obtained, which is a weak alkali because it dissociates to give NH4 plus ions and partial dissociation OH minus ion. It's a partial dissociation, low concentration of hydroxyl ion is produced. Now when you dip a red litmus paper into ammonium hydroxide solution, it turns blue, showing it is alkaline. The other indicator used is phenolphthalein. If you take pink color phenolphthalein and if you take colorless phenolphthalein and you add it to ammonium hydroxide, it turns pink. Phenolphthalein has two colors, colorless and the other one is pink. Colorless phenolphthalein turns pink, showing it is alkaline. Methyl orange turns yellow. Methyl orange is an orange colored reagent indicator. It changes to yellow when added to ammonium hydroxide, again showing it is alkaline. So these are indicator properties of ammonium hydroxide. Now ammonium hydroxide, because it is an alkali, it will react with acids to give salt and water only. So this reaction is called a neutralization reaction. An acid reacts with an alkali to give salt and water only. That is called neutralization. Ammonium hydroxide, the first acid we have is hydrochloric acid. We get the salt NH4Cl, ammonium chloride, and we get water. So this is one neutralization reaction. We have the other neutralization reaction with the other acids, that is, let us take nitric acid, ammonium hydroxide plus nitric acid. So it will give NH4 NO3, ammonium nitrate plus water. Because it is hydroxide, it will give water also. Ammonium sulfate will give, ammonium hydroxide with sulfuric acid will give ammonium sulfate, NH4 whole twice SO4, 2 molecules of NH4OH. So you get 2 H2O. Ammonium sulfate is formed. This is ammonium nitrate, NH4 NO3. This is ammonium sulfate, NH4 whole twice SO4, ammonium sulfate and water. Yes. Then ammonia gas, or its aqueous solution of ammonia, reacts with aqueous solutions of metallic salts to give insoluble metal hydroxides as precipitate. Metal hydroxides are formed. You take FeSO4 in the aqueous form. FeSO4 is iron 2 sulfate, right? And you take NH4OH, ammonium hydroxide, which is also aqueous. So what you get is a metal hydroxide, FeOH whole twice, which is insoluble, and therefore precipitation occurs, and also you have the color NH4 whole twice SO4 is formed along. So this has a pale green color, pale green PPT. Okay. Now if you take iron 3, that is FeCl3, iron 3 chloride, and you take ammonium hydroxide, NH4OH, here you have, this is also aqueous, this is also aqueous. So what you get is FeOH whole thrice, and because iron is in plus 3 state here it is in plus 2 state, and you have NH4Cl, that is 3 NH4Cl. Here it has to be 2 NH4OH and 3 NH4OH. So this is a brown PPT. This is the observation. The observation is brown PPT. Here the observation is pale green precipitate. PPT means precipitate. As insoluble substance settles down at the bottom of a solution, that is called precipitate or PPT. If you take lead nitrate solution and you add ammonium hydroxide here, or aqueous solution of ammonium hydroxide, what you get? You get PbOH whole twice, lead hydroxide and ammonium nitrate. This is a you'll have to take 2 NH4OH and 2. So this will be a white PPT, white precipitate. Then if you take zinc sulfate and ammonium hydroxide, you will need 2 of this, you will get zinc hydroxide and 2, and you get NH4 whole twice SO4, ammonium sulfate is produced here, and you find this is a again white precipitate, gelatinous white precipitate. You take copper sulfate. Copper sulfate is already a blue solution. NH4OH is taken, 2 molecules of this. What you get is copper hydroxide plus NH4 whole twice SO4. The ammonium salts formed here, they are all remaining in solution because they are soluble. This will be a precipitate. Okay, this will be a whitish blue precipitate. Whitish blue precipitate, or you may write pale blue precipitate. Okay. Now, the copper hydroxide formed here, if you add excess of ammonia to it, this product, along with that, if you add excess of ammonia, you get tetramine copper sulfate. Tetramine copper 2 sulfate is produced. It is a complex, so it will form inky blue solution. So, pale blue solution, blue solution added first gives a whitish blue precipitate, which will dissolve. The whitish blue precipitate dissolves if you add excess of ammonia, dissolves in excess of ammonium hydroxide NH4OH to give inky blue solution. Inky blue solution. This is the observation. Inky blue may be otherwise described as deep blue. Okay, so solution is formed. This is the color change that is happening. This is an important observation. So these are the properties of ammonium hydroxide. So students, I suppose you understood the properties of ammonium hydroxide. You may write the equations again and again for practicing. Thank you.